how we got there. I'll talk about plant associations. And then, if we have time, I'd like to just kind of go on what are plants' basic needs and all the environmental constraints they have. So why do we see plants in different kind of communities, places in the earth? Okay, which one of these did I do here? This one? Okay. Okay, so I just have two slides about the different terms we use. And an ecological system is just plant communities that tend to occur in a landscape because they share the similar, ecological process, habitat, substrates. So you would think the same kind of plants that have to adjust to a certain soil are going to be in one area or not. But we don't always target all those ecosystems. What we want to see in a park are a subset of those. And there's certain target ecosystems that the Washington Department of Natural Resources and their Natural Heritage Program created. And there's a publication that came from, and I'll explain a little bit about how they inventoried all the different plant communities in the whole state, of which we just have a subset in Seattle. So we're drilling down a little bit more. So what's a target forest type? That's the dominant plants in the highest canopy within an area that we'd like to see in the greater Seattle area. And so you need to kind of understand where we are in the Puget Sound, in Western Washington, and why would those plant communities happen to occur in Seattle. And then even farther down are the plant associations, and the way they're kind of abbreviated is the first two letters of the scientific name is just a quick shorthand for the dominant species within that, the dominance of that assemblage. But it doesn't mean that's the whole palette of plants that are in that ecosystem. So this is just a lot of text, and I just wanted to give you a farther back perspective of plant communities. So this is from like 1883, some of the original surveying done before we started cutting forests down and altering the landscape. And this map's color-coded by the density of forest. So a big conifer forest is going to be this dark green. So the Olympics, kind of the lowland foothills here. Whereas right next to river valleys, the salt water was a lighter green. So that was more of a deciduous forest, scrubbier habitat. As you go up alpine areas, the density of conifers gets less, more to altitude. And then you finally, when you're over in eastern Washington, it's all scrub shrub, and there's no big conifer forest. So that gives you a perspective that much of western Washington was dense conifer forest. Of that, a subset is close enough to Puget Sound lowlands. So that's excluding all of the alpine areas, montane, river valleys. So this map kind of shows the lower elevation areas in both Washington and British Columbia that share a similar climate, soils, geologic history. You would think the plant community to be the same there, just because they experience the same environmental constraints. So the Department of Natural Resources did this inventory of the entire state, and on a big scale, they lump things in whether it's just vegetated, it's herbaceous, woody, upland forests. Those are just more physical strata layers. But then of that, they classified like 102 different plant communities in the state. And that's anywhere from eastern Washington scablands to western Washington forest to tidally influenced tide flats. So you can imagine there's a lot of variety of plant communities in the state. And the Puget Sound lowlands is just a small subset of that. But it's useful as a reference of what kind of what the ecosystem ought to be if we hadn't manipulated it.
Where's that available, the field guide?
I'm not sure, but
it's on the Power Natural Resources site. I can include the link to follow up.
yeah. And so this is just like a picture out of it to give you an idea. So they have maps like this for all the different plant communities, and it starts with kind of the geographic area. It's in the North Pacific. The climate is kind of maritime, dry to Mesic. Then it talks about the dominant plant. It's a Douglas-fir western hemlock forest. And then they show you the distribution of that in the whole state. And so it kind of clues you in that it's somewhat matched that 1883 dense conifer map you saw earlier, where Olympics, the foothills of the Cascades were the deepest conifer forests. You're not seeing it, out on the peninsula where it's more deciduous or whatever. So this is just one of the pages in that book that we use as an idea of what the reference forest ought to be. So a sub-part of that is these different kind of target ecosystems, and I've just listed a few of the ones that we see the most in the Seattle area. There's a conifer broadleaf evergreen mixed forest, and this is your really dry sites where it's Douglas-fir, madrone, salal, where it's definitely xeric conditions. Then there's kind of more of a medium one where it's dry to Mesic, and you get both conifers and deciduous forest. And there you still have the Douglas-fir and salal, but you might start seeing, you're not seeing the madrone anymore, or ocean spray, evergreen huckleberry. The real dry species start falling out. You get more kind of the middle of the road ones. And this is on the other extreme where it's a little moister kind of environment. So you start picking up the deciduous species, like big leaf maple, alder, but you're starting to, get real wet things like devil's club and, fringe cup. So this is just a sampling of how some of the target forest types we see in our city parks, are categorized, what the dominant species are. So then now I just want to give a couple examples so you see pictures of them and stuff. So here's Douglas-fir, salal in the understory, sword fern. You see it's pretty shady. There's not a lot of light that gets to the forest canopy. It's going to be, it's evergreen kind of dominated. So both the trees and the shrub layer, even herbaceous, are all evergreens. Fairly dry soils. Here's another type of oak woodland that's Gary oak, Douglas-fir, snowberry, and so real sandy soils, dries out in the summer. A little bit more light gets in because the trees are farther spaced apart because they're competing for water. But they like really sandy, dry soils. All right. So, I've characterized some of the target plant communities and what their names and species are, but then you got to understand why do they appear in certain city parks. Other areas have a deciduous forest. So I thought I'd just delve a little bit into what plants need. So here's the basics. Elizabeth, this packet here. I have 3 pages of handouts here that you just hand them all out. That I wanted to go through instead of having it up on the screen. It might make it easier for you all to read.
Also, some of the handouts that were on the table, you got those. Also have some of the breakdown on micro types and has the four-letter acronyms for some of the plants with the whole plant list, plant name next to it.
Okay, so, these are big categories of what plants need, but, obviously light and water and good soil and the nutrients. But I want to break it down a little farther and like where we are in the world. So the length of the growing season is somewhat, a matter of where we are latitude-wise. And that has an influence on the temperatures we see, the day length, the sun angle, what plants have to deal with. If you were at the equator, where you have much more day length and the sun angle is different, you're going to see a different plant community. But we're, at 48 degrees latitude, it's much more temperate. The amount of rainfall we get, both in the winter and the summer, have a big influence on the plant communities we see here. And I don't know if it's, it's going to influence the palette of plants we're going to see. They have to be able to survive the 3 months of summer drought, but they also have to tolerate being saturated soils in the winter. The extremes in temperature, because we're so close to the water, we don't have real deep freezes, and we don't have really high temperatures in the summer. But if you were in eastern Washington, you would get bigger extremes in temperature. Plants have to adapt to that. So we have somewhat kind of moderate extreme, they don't fluctuate too much, and that selects for certain plants. The type of winds we get, how strong a root system they have to have. The aspect has a big bearing on, things like madrone really like a south-facing slope, a marine shoreline where they get full sun. They're not going to do well on a north-facing slope and dense cover. That's just not the habitat they like. So it kind of explains why there's madrones in certain bluffs along the water and you don't see them other places. The amount of soil permeability. Plants have to be able to root into soil, and if it's too hard and rock, they can't get enough water and nutrients. But at the same time, if it's too loose, they'll fall over in windstorms. That has a bearing. And then the amount of the nutrients and the minerals in the soil. And because we get so much rain in the winters, a lot of the nutrients and minerals get leached out. And so native plants have to deal with actually kind of a very sterile mineral soil. There's not a lot of nutrients there for them. And so then those are just basic levels. So I just wanted to give a couple examples of, I'll just do one more. Oops. So here's an example of a dry conifer forest. It's a Douglas-fir, salal, sword fern dominated thing. So it's going to be a well-drained mineral soil, has low nutrients and minerals, dries out in the summer drought, but it isn't too wet in the winter so that the roots would rot. So the adaptions the plant have, they're all evergreen leaves. Think about it, Douglas-fir, salal, sword fern, all keep growing all winter long. They don't have to shed their leaves. So that gives them a competitive advantage over some of the deciduous species. They tend to have deeper root systems, trying to get that water in during the summer drought. Whereas a different type of plant community, a deciduous-based one, has more moist soils. This is going to be like big leaf maple, alder, sword fern area. So there's a lot more water in the soils all winter long. But likewise, even into the summer, there tends to be a moisture soil. So these plants don't have to be evergreen. They can drop their leaves in the winter, and that's their adaptation to that condition. Their root systems tend to be shallower because they don't need to go deep for water. And so oftentimes the water table actually inhibits their roots from going too deep. They're going to want to stay out of that permanent water table. So This is just my idea of trying to explain why we set up these different target plant communities. If you know that your park is supposed to have this Douglas-fir, salal, sword fern one, and then you look at the setting, and it's like, oh yeah, it's a sandy soil. This would be appropriate for that plant community, but it's also historically what would have been there before we logged this area. And in some parks, you have a stream, and it's very wet, and there's groundwater seeps, and that wouldn't be an appropriate plant community. So you're going to want to have a Mesic or a riparian plant community there to take advantage of the water. So that's why we try to create a mosaic of plant communities that are appropriate for each condition. That's all I got. Any questions?